Is 10.2 products and quotients of functions. Now the previous one were sums and differences, and this works exactly the same, products and quotients of functions. It goes with text pages 488 to 495, and so we will be receiving those textbooks shortly. So the first example is, given if f of x is x plus 1 and g of x is 2x minus 3, write an equation h of x if h of x is the product of those two. And by the way, you can write it this way, and just like in the sums and differences, you could have two ways to write it. We can say f times g of x as well. So this is another way of writing the same thing. Let me just zoom in a little bit here. All right, and see if we can get some color on that. So when we multiply this together, really we're just using good old FOIL here, right? X plus 1 multiplied times 2x minus 3. So we will get 2x squared minus 3x plus 2x minus 3. Combine the like terms, 2x squared minus x minus 3, and there's our answer. Done. Write an equation for k of x if k of x is equal to, now this is the quotient, we're dividing instead, so k of x will be equal to, now f of x is x plus 1, g of x is 2x minus 3. Can we divide this any further, or is there anything that we can simplify? Are there any common terms in the numerator and the denominator? No, there aren't any. So this is as far as we get, and that's our answer. Okay, so this reminds me of the graphing rational functions unit we had, right? X plus 1 all over 2x minus 3. Now it says identify the domain of the graphs h of x and x of x. And note, the function in the denominator can never be equal to 0. Therefore, in our example, g of x cannot be equal to 0. Well, why don't we do the first one, the product, the h of x one first. So let's examine if h of x, our definition is it's 2x squared minus x minus 3. So the two things that we're looking for, the things that we're wondering about, is one, is there any situation where we're dividing by 0? That is, if so, we need to restrict that from the domain. And the second one is, are we doing the square root of a negative value? Right? So the square root of a negative, I just put a negative sign in there. In this case, neither of them are happening, are they? You can put anything in for x, and you will not be dividing by 0. You can put anything in for x, and you won't be doing the square root of a negative. So we can say here that the domain is x can be all real numbers. Okay? Or another way you can write this is you can say from negative infinity to positive infinity. Okay, two ways of writing the same thing, that x can be pretty well anything. So for our second one, for k of x was equal to, what was it, x plus 1 all over 2x minus 3. So now we do have a division by 0 possibility here, don't we? So that's where we're going to have to restrict the domain. So we're going to say, okay, 2x minus 3 cannot be equal to 0, because otherwise we'd be dividing by 0. So 2x cannot be equal to 3, so x cannot be equal to 3 halves. So we would say, oh, x can be all real values, but x cannot be, here I'll put in a box around my answer, but x cannot be equal to 3 over 2. If we wanted to write it in interval notation, we could say, well, if we start from negative infinity, right, all the way up to 3 halves, but not including 3 halves, so we do the open bracket here because it does not include 3 over 2, and then we say the union of that set plus 3 halves to positive infinity. So this is set notation, set builder notation, an informal version of set builder notation, and there's interval notation. So you can put either one in, but you should be familiar with this, what that second one means. Okay. All right. Example number 2. If h of x is equal to 2x squared minus 5x plus 2, and h of x is equal to f of x times g of x, right? Two possible solutions. So they're giving you the product, and they want you to find two functions that will multiply and figure out the original. So really, it's a one-word answer. If I tell you this word, you'll say, oh, that's not so hard. The answer is, the hint is factor. So if we take a look at our 2x squared minus 5x plus 2 and we factor this. Okay, so we're looking for two values whose product, the product of 2 and 2 is 4, product is positive 4, and whose sum is negative 5. So what are two numbers who multiply out to positive 4 and add up to negative 5? I'm thinking it's going to be negative 4 and negative 1, right? So if I go and say 2x squared, and this minus 5x now expands out like this, and now if I group them, I'll get 2x squared minus 4x. And now if I say minus, and I group this, be careful, because this plus 2 turns into a minus 2. And if you can just kind of multiply it back just to make sure. Minus times x gives you minus x. Minus times minus 2 gives you plus 2. And now we're ready to factor out a common 2x here. And we get x minus 2 minus x minus 2. So you can think of a 1 being right here. And now we're ready to say 2x minus 1 multiplied by x minus 2. Okay, so we factored it, so now we're ready to answer the question. Maybe I'll switch to another color just to keep track here. If h of x is equal to f of x times g of x, there's a possibility. F of x could be equal to 2x minus 1. G of x could be equal to x minus 2. Two possibilities. Or, well, we could switch them. We could say f of x is equal to x minus 2 and g of x is equal to 2x minus 1. Now, is that the only possible two answers? No, those are the no-brainer answers. The sort of like, hey, obviously this is probably what they're looking for. But what about if we just said if f of x was equal to 1, right? Then g of x, oh, I'm disappearing. G of x would then have to be 2x squared minus 5x plus 2, right? There would be another example. Or, heck, you could go and say, what if f of x is equal to negative 1? Then this would be negative, positive, and then negative, right? So there's really an infinite number of answers, but these are probably the ones that you would find in your answers at the back of the text. So if you get something that you can factor it, right? If not, you really could kind of cheat and just say one of them is 1 and the other one is the entire original function. All right, example number 3. Using the graphs f of x and g of x given below, answer the following questions. Identify the zeros if the function h of x is h of x equals f times g of x. Okay, so identify the zeros. What are zeros? So zeros, well, here is a 0, there's a 0, there's a 0, okay? So one way to look at what is a 0, it's where a line crosses which one? The x-axis, right? That's one way to look at it, okay? Another way to look at it is, well, let's look at this one. The x value is negative 2, and the y value is 0. So it is the x values that produce a 0 in the y values. So if I have a function, so f of some number is equal to 0. So what number would you have to put in here when you plug it into the function comes out as a 0? Okay, so if this, let me see, f is the straight line, and g is the parabola in this case. And our first question is, identify the zeros of h of x of the product. Well, and the hint is, when either f of x is equal to 0 or g of x is equal to 0, the product will also be 0. Because remember a long time ago, you know, your math teacher might say, what's 3 times 4 times 8 times 2 times negative 1 times 0? And as long as they said 0 once in there, the answer was 0. So in this case, if we're multiplying the values together, then as long as one of them is going to be equal to 0, then the product will be equal to 0. So the answer to the first question is, identify the zeros. It's going to be negative 2, negative 1, and 0. And those are those three spots that I identified right there. Okay. Evaluate the following expressions. F over g at 1. So this is going to be the same thing as f of 1 divided by g of 1. So what does this mean? I plug in my x value at 1, and I find out what my y value is, and I put it in the numerator. Okay, so at 1, it seems like my f is z at 1. So over here, at 1, I'll switch to blue so we can tell the difference. At 1, so my g value is equal to 3, so I could say g at 1 is equal to 3. And over here, f at 1 is equal to negative 4. So it would be equal to negative 4 over 3. And we can just leave it like that. Negative 4 over 3 is a fun way to write it. You don't have to. I'd rather have that than negative 1.3 repeating. I kind of like it as a fraction, as a rational expression, rather than a decimal. All right. The second one was f times g at negative 3. So at negative 3. Oh, let's go red for this one. At negative 3. So that one is g, right? So g at negative 3 is equal to 3. And f at negative 3, sorry, I should have put negative here, at negative 3 was equal to 4. So it's a 3 and a 4. So it's equal to 12. Okay, f at 0 and g at 0. I'll go black on this one at 0. So this one is g. So g at 0 is equal to 0. F at 0 is equal to negative 2. So it would be equal to negative 2 over 0. Did I get that right? The g... Yeah, that's right. So can I divide by 0? No. So we could say undefined. Okay. So you can't divide by 0. Alright, so for your homework, you have these questions here, and I will probably be giving you an entrance slip, so please look in the comments. I haven't made it yet, and check for that. Thank you very much.